In this video, I'm going to talk about flowcharts. So flowcharts are a graphical way of representing a code or an algorithm. Maybe you've seen flowcharts before, so I'm going to show you a couple examples that I found online. So this first one is a troubleshooting flowchart for engineers, and we start here, and the flowchart asks us, does it move? Yes. So maybe whatever we're working on moves, yes. And should it move? If it should not move, then we use duct tape. If it does move and it should move, then there's no problem. Does it move? If it does not move and it should not move, no problem. If it does not move and it should move, then we use WD-40. So these are kind of our two solutions here, duct tape and WD-40. So two magical solutions there for engineers. On this next one, it says how to decide if you need a flowchart. So we have kind of three starting points here. Our flowcharts, we're all going to start with one start point. So then we could imagine that we have these three different options here. So maybe that is an if, else if statement, which you'll see later in this module. So maybe we have a simple task. So is it a simple task? Sorry, is what this is asking us. And if it is a simple task, so let's say yes. It says, excellent, this flowchart should be a cinch. So then we make a flowchart. And then it says, already have a flowchart? Yes. But do you have a backup flowchart? Yes. What if you lose your backup? Make a flowchart. So this is pretty much, we can see that all lines lead to flowchart. So just pick your own adventure here. Maybe you're in a hurry. This is what I often hear from students. You all are very busy, so are you in a hurry? Yes. And then it says, you got to use your time wisely then. So create a flowchart, because using a flowchart could help you code better and more efficiently, and could end up saving you time in the long run. Okay. One other example, this is a nice joke example, or you can take it seriously. I do not take any responsibility for what you do and do not eat off the floor based on this flowchart. So you dropped food on the floor. Do you eat it? So the first question, did anyone see you? So maybe no. Was it sticky? Ooh, yes, it was. Was it a raw steak? No. Did the cat lick it? No. And this flowchart says we should eat it. If the cat did lick it, yes, and your cat is healthy, then I guess you should still eat the thing you dropped on the floor. So again, no responsibility for what you do based on this flowchart. Here we have a trap flowchart, so it says start. And it says, hey, wait, this flowchart is a trap. Yes. And then we loop back to where we started, and it says, hey, wait, this flowchart is a trap. Yes. And we keep going and going and going because it's a trap. Okay, so let's look at some of the shapes that we often use in our flowchart. So the first shape that we use is this oval, and it will either say start in it at the beginning of our flowchart, or it might say stop or end at the end of our flowchart. Next, we have our arrows, which show our direction of that we're going. So we saw arrows in all of these. I guess that one's just lines, but our arrows show us which way we go in our flowchart. Next, we have our parallelogram that will be an input or an output. So an input or an output could be x equals 3. Our rectangles are going to be a process or calculation. An example is x equals x plus 1. our diamonds are going to be a decision. So this is where we ask a question, and we typically have two different options, yes or no, true or false. So something here could be, is X less than 4? Now let's go through some examples. So let's say I want to write an algorithm that checks if a number, I'm just going to use a variable here, n, is divisible by 12. So maybe it's hard to look at a number and automatically tell that it's divisible by 12. So there are two things that have to be true in order for a number to be divisible by 12. One of those is that it's divisible by 3. And it has to be divisible by 4. And it's slightly easier to check if a number is divisible by 3 or 4. So let's draw a flowchart for this algorithm. So we're essentially going to check, is our number n divisible by 3, and is it divisible by 4? So I'm going to start my flowchart here with a start. And I'm going to input n equals some number. Let's just pick 90. And I'm going to start by asking the question, or I'm going to keep this general. Sorry, here I'm just going to say that we define n. So the user is going to input some value n. And here I'm going to ask, is n divisible by 3? I'm going to draw my little diamond. This is a yes/no question, so if it is yes, then we want to check, is n divisible by 4? If the answer is yes, then we know that n is divisible by 12. If the answer is no, both of these are going to lead to the same place, then n is not divisible by 12. So if both of these things are true, so we have a yes and a yes, then n is divisible by 12. If either of them is not true, no or no, then n is not divisible by 12. And you'll see later in this module how we can code this using what's called an if statement. And this is actually an if statement inside of an if statement. And here we're just gonna stop our program or end. So that's our flowchart for this example. Let's do one more example flowchart. For this example, we are going to write the algorithm for the Euclidean or Euclid's algorithm. This algorithm helps us find the greatest common denominator, greatest common divisor of two positive integers. So this algorithm starts with two positive integers, a and b, and the output is going to be the greatest common divisor, so the greatest number that can be evenly, the a and b can both be evenly divided by. So first, we always want a to be greater than b. We're going to divide a by b and then get the remainder. If our remainder is 0, then b is the greatest common divisor. If the remainder is not 0, then we're going to replace a by b and replace b by r. And then we're going to return to the step where we divide a by b and get the remainder. So let's write that in flowchart form. So we're going to start. We're going to define a and b, or sorry, we should go through an example first. I realized that I just said it all out loud. So let's go through an example. We're going to start with maybe 210 and 45. So we're going to start and say 210 divided by 45. It's going to be 4.667, so 210 minus 45 times 4. So our remainder here is 30. And I found the remainder. There is a MATLAB function to find the remainder, but I did it by saying 210 minus 45 times, I'm going to use some MATLAB syntax here. So I did floor, which means round down, of 210 divided by 45, which is 4. So 210 minus 45 times 4 is how I found my remainder. So that remainder is 30. Is 30 equal to 0? No, it's not. So at this point, first I should have said here, a is equal to 210, b is equal to 45. So at this point, the remainder is not 0, so we have to go to our next step where we replace a with our old b. So a is going to be 45. We replace b with the remainder, 30. So then we're going to have 45 divided by 30. Our remainder is equal to 15. Is 15 equal to 0? No, it's not. So we once again need to say that a is equal to our previous b, 30. B is equal to our remainder, 15. And here we're going to say 30 divided by 15. Our remainder is equal to 0, which means that 15 is the greatest common divisor of 210 and 45. So 210 divided by 15 is 14. 45 divided by 15 is 3. So 15 is the greatest number that can be evenly divided into both 210 and 45. Now let's write our flowchart. So we're going to start. And the first thing I'm going to do is define A and B. And then I'm going to find the remainder. This is the great thing about flowcharts, is if I didn't know to find the remainder this way, or if I didn't know that MATLAB has a remainder function, I can still write my flowchart or my pseudocode, and then I can figure out how to find the remainder. So here I'm just going to write that I need to find the remainder of A divided by B. And let's set that remainder equal to a variable r, so we don't have to keep writing the word remainder again. So that is a calculation. I'm going to put it in a rectangle here. And then I'm going to ask the question, is r equal to 0? When we're checking if something is equal in MATLAB, we use two equal signs. If you don't put that in your flowchart, that's okay. I just like to do it because it's a nice reminder to myself to put two equal signs in my code. So if this is true, yes, that means that B is the greatest common divisor. Great. And that can be our output. And then we're done. We can just stop our code. If it's not true, so if the remainder is not equal to 0, then we have A and B. So we can say A is equal to B, and then B is equal to R. So we replace the values of A and B, and then we're going to repeat the step. Where we find the remainder of A divided by B, and then we ask the question, is R equal to 0? And because we're going to keep repeating basically this and then this again and again until it's equal to 0, this is where we end up with a loop. So we can loop back to here to ask, or even we could go in here, is R equal to 0? So whenever we see our flowchart form a closed loop like this, this is going to be a loop, which in this week's module you'll learn about for loops. Next week's module you'll learn about while loops. So this is our finished flowchart for Euclid's algorithm. So it looks like we have an if statement here, which you'll learn more about later in the module, as well as a loop. Flowcharts can be a really great way to kind of organize your thoughts and start planning your code. You don't always have to write a flowchart, but they can be really, really useful. Sometimes when I'm writing a really difficult code, I don't write the flowchart for the entire code, but I'll write it for certain parts of it, especially if I'm having a logic error and I can't figure out where my logic is going wrong. Then I'll write a flowchart to kind of help me make it through that, debug, and figure out how to make the code.